So 123D looks like this when you open, so it has nothing in it. It's a very simple, easy software to use. So you would do an import, go over, you have. Okay, I sent you guys a link. It was finding that link was as easy as going online, looking for 123D make download, and then there is a website called Autodesk 123D make enlod.com, which is a little bit suspicious, but it allows you to download. So just click on download, and then there's a mirror file you can download, and then after 6 seconds, it will give you an exe file that you can download or install. I have sent you guys the link to this and also the link to that through an email, but it's pretty straightforward. And then after this, you'll just install it easily. It may ask you to log in with your educational Autodesk account, which you will do, and you will have access to the program. So I'll have done my import, and then you can see that it is showing the geometry here for me. Before doing anything else, there's a sign-in button up here. I'm not sure, but it may limit your access to some of the tools if you're not signed in. So I would recommend going back and signing in, even though it is not a really Autodesk program anymore because it's discontinued, but it's good to sign in. Anyways, so I did an import. It brought me the geometry in. Navigating is very easy. Right click, you can orbit around. With pan, you can pan around with the scroll click, and scrolling in and out will zoom. On this side, you have a few tools that is very obvious. So you want to see in perspective or ortho, and then you can zoom, extend, zoom, and pan and rotate and that kind of thing. So that's pretty straightforward. Over here, these are all panels. So those buttons do nothing for you. It's just selecting a menu to work in. So if you want to see your model, it is showing that it's one OBJ, and how this works. This is your manufacturing setting. So this is kind of important to know. If you're under this menu, you're defining what is the sheet you're cutting from and what is the specifications of that. There are some presets that you can use over here for sizes of the sheets. So if you go there, you can select from these, but you could also make your own kind of sheet. So I've clicked on this, making my own thing. I'll just cut it sheet. Then you can define what the units are, what is the length of the thing I'm dealing with. So I'll just say 11 by 26. I think that's close to what you guys use in the shop, but whatever those accurate numbers are. You will define the thickness here that Branko was talking about a lot, which is very important. You can define it here, and then it will calculate the thickness of your material. So if there are hinges or connections, it will have that already calculated for you in it. Then some margins, offsets for your cutting tools and all that has been set up here in your sheet. So you will make your sheet with the information you have, and then you will go forward. Next one is the object size menu or panel. So again, you talk about the units, what is the height, and then what are some of these dimensions that I'm dealing with here. I will make my geometry a bit smaller just for it to fit easier on the pages. Then I will show you how to deal with that. So those are the basic setups. After that, you will look at your construction techniques. So it gives you a few different tools to use. First one is the stacked slice. So you will click on that, and you can see that it has stacked sliced your geometry. Given the thickness I have already defined in my sheet, I can go back and change that and say the thickness is not that, the thickness is less. So 0.1, done. I think those are duals. It's not doing that. I'll figure that out. But anyways, so it does that for you. You can add some dowels in your geometry that you can add more or less and move them around. It will just cut a hole through your geometry, and then you can put your dowels in, like columns that will hold your pieces. You will define what's the diameter of that. element, and then you can also add more if needed. So that you can, when you're stacking things, you need something to guide you through how to assemble at the end of the day. You can define the shapes based on the tools you're having. You will give it the information. Then you got the slice direction. So you can, it is slicing horizontally for me now. I could change that to a different angle. So using that, I can turn it 90 degrees, so it's cutting the other direction. Or I could even give it a random somewhere in the middle angle, and it will do some interesting effects like that. So that's how you will deal with the slice direction. Then you can modify your form. I'm not going to change it here a lot, but you can make your geometry hollow, give it thicken that, or shrink wrap it. I'll just show you quickly how to do a hollow geometry. I'll go back and make it a bit more, a better understandable angle for your contours, so that we are dealing with a less crazy geometry. Then I would go to modify my form. I want to hollow that, and you can see this little thing in the middle is the hole it's creating here, and it will show up in all the cut tools. I'll maximize it and say apply. Now all my geometry has a thickness and is hollow. So as you can see here on the side, it's showing me a cut sheet that I can laser cut. So these are all the different layers that I will cut, and all of them are hollowed. So that's that. And then it will show me the assembly steps, which is a pretty cool tool. I really like that, especially when it gets more complicated. So it will show you all the steps of assembling your pieces together and getting there. And then at the end, you can get the plans. Let me take a look and see why this thing did not work. Oh, the reason was that I haven't picked that. So after making that new sheet, I had to pick it. Now you can see it's a bit more. I have a higher resolution, and the pieces are better defined. Okay, going to the last one. I'm just gonna make my model a bit bigger so that I'm dealing with more sheets, not just one. There. Now you can see a very high resolution, a very actually beautiful geometry there. Just to give it a better, make it a better example, I'm gonna reduce those to an 11 by 17 sheet size, just for this conversation. There. Okay, good. So when I go to get plans and click on this, it will open up this sheet for me. So based on the sizes I'm dealing with, it will give me a configuration over here. So the layout it is putting there is simple, meaning that by the order of how you're gonna assemble it, it has just laid this on the sheets. You could also do nesting. It will think a bit more to have more efficient use of your material and put them all together in a way that they are even inside each other, and it has tried to fit this very well. You could do use a nesting script in Rhino as well if you're working in Grasshopper and Rhino, but here it's very simple and straightforward to do that. The challenge here is that you cannot really, then you will pick if you want to do a DXF, PDF, or EPS. Almost all of them you can export and use it in Illustrator and define your cut lines and all that. I'm going to quickly show you that probably at the end, but I'll say just PDF. The units are defined here, and as soon as I click on export, it gives me an error. I'm not sure if it's an error in the program or if it's because it has been discontinued. I've tried signing in, all of that, it didn't work. But the easy way to work around that is to just click print and do a PDF print out of your sheets. Then it will let you to do a print. Okay, I'll go to my drive C, Alex's drive C actually, new folder, and save it there. Don't ever save your files as one. 2, 3, give it proper naming all the time. So here in new folder, now I've got my PDF file. Very beautifully and cleanly, it has put all the geometries in, but it has cut a portion of it because the print sheet size was not matching the 11 by 17 that I had. So I would go to Properties, Advanced, Paper Size, and then I would give the proper paper size there so that I can export it with the size that I need. Any questions so far? No? Pretty straightforward, right? Okay.
So you do one about it, and you either open it here or you open it and run and do what you said.
Yeah, you do unroll there, which is good. But you could also do it here. The good thing about this is that it will do all the labeling for you already. It will calculate the thicknesses, do the hollowing. Everything is ready made in this for you, which is a pretty amazing thing to have. I mean, stacking is pretty straightforward, and you don't need a lot of help figuring that out in Rhino, but it does a lot of things for you. So to show you a few other things, so construction techniques, I started with the first one that was just stacking. The second one is interlocked slices, and this is pretty interesting too. I'm sure Branko have showed you an example of this being used. Kind of that library thing looks like this. So it picks two different axes and try to, given the numbers you define here, create this geometry that interlocks slices to form your geometry. This is also a pretty interesting technique to use. So same thing, you can change the direction of slicing, and maybe your geometry has something interesting going on in it that you really want to show here with changing the direction of slicing. And then again, my favorite tool, the assembly, will show that you will place this in, and then all these pieces will go in, and then the second axis will just interlock and fix that. So that would be, that one wouldn't hold. But again, you will go there, you will see all these cuts has been already defined for you, all the numberings, what goes where, how to assemble, all the tagging has been in place. So it's a very clean and simple program to use, very powerful. The other technique that you could use instead of interlocking is curves, which I couldn't really understand what they mean by curves, but very similar to interlocking, but just a bit differently. You can see, again, you can define your axes and then you can assemble this. Next one is the radial slices. So again, similar to this, but on a radial fashion. As you can see, it does that. And then when you go to your assembly steps, you can see you would place in the first one and then place all your levels into it. And then radially, you would go around and add all the interlocking pieces into your geometry to form that. So depending on how your final geometry looks like, you will bring them here and explore a few different tools to see which one is closest to the one you wanted to achieve out of the fabrication. One thing that a lot of you will end up using probably is the folded panels, which is one of the most architectural tools that it has. So it will basically just divide your thing, very similar to the unrolled surface thing in Rhino that I showed. It will divide your geometry into pieces that you can cut and fold and assemble. So over here, it has defined a few things. It doesn't have, unfortunately, an assembly simulation that I can show you, but it will give me all these pieces that I can cut, score, fold, and put together. There are a few more controls that I will show you to avoid this going off of a sheet and that kind of thing. So if you go here, when you're dealing with the folding panels, first of all, you can change your vertices counts, so reduce the number of vertices in your geometry. You can split your panels. If you want, you can get all the triangles separately. I don't recommend that, but it does a good job in numbering them. So The other thing is that you can add seams. So as you can see, this one, for example, is a very giant surface that you may have a hard time fitting that onto a sheet. So if you can identify that in your geometry, which looks like is this bigger piece over here, then you can go and add a seam. So it will let you pick seams and then do done down here. So if you click on done, then it will cut that geometry into smaller pieces. So it's still a bit big, but now a portion of it is cut and placed in the other sheet. The other tool is the joints. So as you can see, these are these small things that it is putting into place, so you can connect your things together using those joints, and you can define different type of joints that are again, a very powerful and interesting tool. So you can do gears, you can do laced if you want to glue them. Oh, sorry, if you want to throw a lace through them. You can do multi-tab if you are thinking about these things going into each other and locking them there. You can do puzzle, you can do rivet, seams, tabs, sticks, or tongues. Look at them and see which one is more interesting for you. Tongue is also pretty cool because it is really kind of trying to do a glue-less assembly. How successful it's going to be at the end, you will figure that out, but it's a tool out there for you to use. And then at the end, again, you can go there and export your PDFs and get your sheets and deal with the model. The last thing that you can see is the 3D slice. Very similar to stacking, but a bit different. And the difference is that it's not made for assembly steps. It's not made for a laser cutter, but it's really made for a CNC mill, but it can cut in angles. So I'm going to show you just my first geometry here. You see it's a flat sheet, but the edges are cut at an angle. So that's what it means by 3D slicing. So each of the sheets have an angle on the sides. You won't be able to get that in your laser cutter, but using a CNC mill, you will be. So this is, again, similar to stacking, just a different fashion of doing that. That is 123D Make.